Z sub C means a Z-score for a certain confidence level. Okay, so what would you guess that the average amount of hours that in a grocery store employee works is?
20.
15.9.
Higher. Close. 29.6. That's exactly what you were going to say.
I was going to say 27.
Oh, you could have lied right there.
Oh, wait, no, actually.
It was exactly
Yeah.
29.6. So, this is the error. Assume the population standard deviation is 7.9, sigma is 7.9, and we're supposed to find the margin of error if the mean number of hours worked by all grocery store employees. Use a 95% confidence level. Now, we just figured out that the Z sub C for a 95% confidence level, we use the positive one, is 1.96. You actually will use the positive and negative one in a second, but I'll explain that. So if we're just trying to find the margin of error, have you heard this before, like on political polls, a margin of error, like how far there might be off by? Okay, it's not just like people guessing, like this is actual math that they're using. So E equals, I'm using this formula right here, Z sub C, that's 1.96 times, sigma goes on top, 7.9 divided by the square root of what? I didn't tell you an N. Let's say that there are 40 people. All right. Go ahead and put that in your calculator. You get about 2.45.
Good.
So that would be the error. All right, go to the second page, and I'll show you how this is used.
What does it mean that the error is 2.45?
Well, what it means is that, which I'm about to tell you, is that in the confidence interval, the mean itself will go in the center of that TIE fighter, and then I'll add 2.45 on the top and subtract 2.45 on the edge to get that error range. So the error is how far I think I might be off from the center. Make sense? Okay. All right, I did a T-table again because you said you guys like that. So, first step is to verify that the population standard deviation is known, or sigma is known. And also it has to be normal, or n has to be greater than or equal to 30. And if those things aren't true, then you can't do the problem. This should just be in the text of the problem. There's no deep dive you have to do here, like it's just written in there. They will occasionally put one of these on the AP test where they'll be like, make a confidence interval with this data, and then they'll say it's not normal and n is 5, and then you would have to say, I can't do this, there's not enough information. Pretty rare though. Number 2, you find the sample stats, n and x bar. What does N stand for?
Number of trials?
Sample size. And X bar? Sample mean. The only reason why you know the population standard deviation is like from a past test. So they might say, from studies in the past, we know that the population standard deviation is about this. And that's the only difference between this and the next section. Next, you find the critical value. Which is Z sub C. That's on A16 and A17. Then you find the margin of error. Formula for that is E equals Z sub C times sigma divided by the square root of n. All right, create the confidence interval. It'll look like this. In the center goes x bar, and then over here is x bar plus your error, and over here is x bar minus your error. That's what I meant when I said that sometimes it's kind of like a positive and a negative z-score you're using. Like if you were to add a positive z-score, it would be this number, and if you were to add a negative z-score, you'd end up over here. And then finally, put it back in context. This is a requirement not in this book, but a requirement in every single AP test. And I promise you that most likely one of the 6 free response questions will be a confidence interval question. And they always like literally write in there, and I'll show you how to grade yourself when you're doing a practice AP test, because they will literally have your score in there where it'll be like, give them this score if they write it in like with context about what they're talking about. So this is a sentence, which I know is devastating that you have to write a sentence in math class, but we can do it if we try really hard. Yeah, I know. Subject, predicate, we're going for it. A college admission director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, the mean age is found to be 22.9 years. From past studies, the standard deviation is known to be 1.5 years, and the population is normally distributed. Construct a 90% confidence interval of the population's mean age. Okay. Step 1. Sigma is 1.5, says in the problem, and it's normal. Check. Number 2, we've got to find our sample stats. We know that n is what? 20. And x bar is 22.9. Step 3, we have to find the critical z-score. You can draw yourself a picture right now, or we can just try to visualize it. Do you want to should we draw a picture, or should we just try to visualize it right now? Okay, everybody imagine. Imagine, I know you're ahead of us, Noah, stay with us. Okay, imagine a bell curve in your mind. Can you see it? Okay, and 90%'s in the middle. What's in the tails? 5 and 5, right? So you need to look up 5% where? In the middle of the table. So in the center of the table. I believe that one falls between 2 numbers. Yeah. Because if you look in the center of the table, this one is 0.04.